Welcome to this module, and in the last module what we have seen? We have seen a diagnosis tool for cancer, right, and we have seen that if you want to understand the change in the tissue properties, you have to have a biochip which can be integrated with 3 different kind of sensors, and that 3 different kind of sensors can help us to understand which kind of property of tissue, mechanical property, electrical property and thermal property of tissue, right. So, if you want to design and now we want to understand the process flow, right, what we can do. So, if you remember the process flow or you can just look at the screen, then you will again remember what is the process flow. The process flow is we will start with a silicon and then we move on to fabricating different structures. The first structure is our heater, right, and this chip is loaded within this 3D printed device or tool, and chip is right over here, as you can see, a microchip or a biochip, right, and it is a press fit contact. You can load the tissue in this area, and we have already discussed how we can work on getting the properties of tissue or understanding the property of tissue. This is thermal property of tissue, electrical property of tissue and mechanical property of tissue, right. So, let us now see the first step, that is our heater. If I want to fabricate the heater on the silicon substrate, what is the process? Process is our lithography, standard lithography. So, I will draw it here and you follow it. Okay. First step. So, what we are right now what we are doing? We are drawing a process flow for fabricating micro heater. Okay. So, the first step is you take the silicon wafer, Okay. So, this is my silicon wafer, alright, 100. On this silicon wafer I will perform RCA cleaning. We all know that we have to perform RCA cleaning, that includes the cleaning or remove the contamination and remove a thin layer of oxide, right, about 1 to 2 nanometer, that is present on the silicon, and then we have to pre-bake the silicon wafer, pre-bake to remove any humidity content on the silicon wafer. This is our first step. Second step, this is step 1. Step 2 is I will grow silicon dioxide, silicon dioxide, silicon. Step number 2. Okay. Step 3. What step 3? Step 3 is I will deposit the material that will be used to form the micro heater, right. I will deposit a material used to form micro heater. So, let us say this material is nichrome, this is my SiO2, silicon, SiO2, right. Next step, what is the next step? This is step number 3, step number 4. Step number 4, will be to spin coat what to spin coat? Photoresist, right, to spin coat photoresist on the metal, spin coat photoresist. We show photoresist by dotted pattern, so that we can distinguish between different pattern. This is your photoresist, then your nichrome, then your silicon dioxide, then silicon, then silicon dioxide. After photoresist, spin coating photoresist, what you have to do? We have to perform soft bake. Now, assuming this is positive photoresist, we know the role of positive photoresist, the role of negative photoresist. So, if we perform soft bake, we can perform at 90 degree centigrade for 1 minute on hot plate, right. Next, what we require? Next, we have to load the mask, right, SiO2, SiO2, right, and then I have nichrome, then I have photoresist, nichrome, SiO2, SiO2, right, and on this what will I do? I will load the mask. What is this kind of mask? I will use a bright field mask. I will use a bright field mask. All right. What we are using? We are using positive photoresist, and we are using bright field mask. After loading the mask and aligning the mask, I will expose it. So, this is my fourth step, soft bake will be my fifth, right, and then loading mask, performing. So, I am not writing in detail, but let us say this is the fifth step, soft bake. This PR, when you spin coat photoresist, then you have to perform soft bake, then you have to load the mask, load the mask. Then after that you are exposing the wafer with UV light, right. After that, what is the next step? So, fifth would be loading the mask and exposing the wafer, sixth would be loading the mask and exposing the wafer with UV light. Seventh step would be unloading the mask and dipping the wafer in photoresist developer, unloading the mask and dipping the wafer in photoresist developer. So, when you dip the wafer in photoresist developer, then what do you have? You have photoresist, you have nichrome, SiO2, SiO2 with this step, right. When you dip the wafer in photoresist developer, you have this pattern. Now you can perform after this next step. So, this one would be 7th step. Next step would be hard bake. Hard bake is done at 120 degree 1 minute on hot plate, right. So, that will be my 8th step. After this I will dip this wafer or I will perform wet etching by dipping the wafer in nichrome etchant. After this what will I have? I will have a wafer, I will have a wafer with what? I will have a wafer with nichrome on the area which was protected by photoresist, right. I will have a wafer with nichrome with the area protected by photoresist. Correct. After this what is the next step? So, if I say this is step number 9, what is the step 10? Step 10 I will draw it here, okay, I will draw it here. After this one is step number 10. What I have to do? Do I require photoresist? I do not require photoresist, right. I do not require photoresist. So, I have to strip off the photoresist, strip off this photoresist. I do not require photoresist, I have to strip off the photoresist, and the stripping off can be done. The stripping off can be done by dipping the wafer in acetone. So, you can say acetone depth or acetone dip, acetone dipping. So, if you see what we get here, after performing these 10 steps we get a nichrome pattern on oxidized silicon substrate, right. Let me repeat this process quickly. Silicon, then we have oxidized silicon, then we have nichrome on silicon, oxidized silicon, then we spin coat photoresist, we perform soft bake at 90 degree centigrade for 1 minute, we load the mask, we align the mask, then we expose the mask with UV light. After that we unload the mask, right, dip this wafer in photoresist developer and develop the photoresist. Since it is a positive photoresist, the exposed area will become weaker and the unexposed area will become stronger. This is what we see here, that the photoresist that was exposed become weaker and it got developed in photoresist developer. The photoresist that was not exposed got stronger and it is still there. After this what we are looking at? After this we have to perform hard bake at 120 degree centigrade 1 minute on hot plate. Next step would be wet etching. Wet etching can be done in nichrome etchant, since our metal used for micro heater is nichrome. And after that when you do perform a wet etching, then you will see that the nichrome in the area which was not protected by photoresist got etched. After this step, the next step would be we have to remove the photoresist or we have to strip off the photoresist, and for stripping of the photoresist we can dip this wafer in acetone dip, right. When we do that, right, and when we rinse the wafer, we can see a micro heater pattern on the oxidized silicon substrate. This micro heater we can inspect in the microscope. So, after these steps, what we obtain? We obtain our step number 1, which is the micro heater, You got it? Now, what is the next step? Next step is we have to pattern interdigitated electrode on this micro heater, but can we do that? No, because this is a metal, this is metal, let us say this is metal number 2, micro heater is our metal number 1. We cannot have two metal on each other, otherwise it will cause shorting. So, we should have a insulator between micro heater and the interdigitated electrodes, we should have a insulating material. So, let us perform that step, and so we get this kind of micro heaters, now we know it. So, now what we have, let us start from micro heater. So, we have micro heater with us, okay. That micro heater we have just seen the process flow, and let us draw here. So, we have this micro heater ready with us. This is our first substrate with micro heater. What is the next step? The next step is that we have to grow silicon dioxide on this micro heater. We have to grow silicon dioxide on the micro heater. Right, and let us make silicon dioxide like this. This is our grown silicon dioxide or deposited silicon dioxide. This is our silicon dioxide that is grown by LPCVD. This is silicon, this is silicon dioxide, this is again silicon dioxide, and inside this one is our heater. This is our heater, right. Next step would be, so if you have this heater, right, you have let us say heater, and it goes something like this. All right, it does not look good. So, let us say draw it properly, then we draw it, goes like this. Okay. Still it is not good, but this is what I can draw. So, now you have metal, right, and on this metal what we have? We have insulator everywhere. Now, if I ask you to tell me what is the resistance of this heater, can you measure the resistance? You cannot, right, because there is an insulating material on the micro heater. But how can I measure the resistance? If I open or if I remove the insulator from the contact area, right, this is contact area, contact pad, this one is contact pad. If I remove the insulating material from the contact pad, then I can tell whether I can take a proper contact or not, or I can measure the resistance in a simpler word. So, here when we have grown silicon dioxide, what we have to do? We have to open this contact area, okay. That is why we have to use micro engineering, right, otherwise we will have this kind of pattern. Okay. So, now I have removed the silicon dioxide from the contact pad. See, drawing becomes so easy. Now, when we want to perform this one, this step where after depositing silicon dioxide we have to remove the silicon dioxide from the contact pad, so that we can measure the resistance. What are these steps? That is what we are looking at. Okay. So, this is our second step. Third step, so I will, this is our first step, this second step. Third step, third step would be spin coating, spin coating photoresist. So, for spin coating photoresist, what I will do? I will put here photoresist, right. I will put here photoresist, and let us say photoresist is shown by a dots. This is photoresist, and here it is positive photoresist. What is it? Positive photoresist. So, what kind of mask I have to use if I want to remove just metal pad and keep the rest of the area as it is? I will use a dark field mask. I will use a dark field mask. So, let us see here, this is step 3, we have coated photoresist. Step number 4, step number 4, step number 4 would be to load the mask, right, to load the mask. So, for loading the mask we will use a dark field mask. Why? Because we want to etch only the area which is your window, window or contact area of the micro heater. All right. SiO2, SiO2, Si, SiO2, and then we have here which is our heater, which is nichrome, right, and then we have our photoresist. So, we will form a photoresist which is shown by dots, dotted pad, right, and then on this what will I have? I have a mask, I have a mask which is dark field mask. Only the contact area of the heater would be exposed, only the contact area would be exposed. Just to make life easy, I have drawn that as if we are opening the contacts like this. When you actually take a cross section, only one side of the contact you will see here, not both the contacts open like this, right. So, it is something like this, and then we have so a mask, this is your dark field mask, dark field mask. After this, what is the next step? Next step is we will soft bake, sorry, after spin coating photoresist, after this spin coating photoresist, next step would be, I missed one step, next step, step number 4 would be soft bake. Step number 5 would be, this is our step number 5, would be load the mask. Step number 6 would be expose, or step number 5 and 6 would be load the mask and expose with UV light, with UV light. So, now I expose this one with UV light. What will happen? What kind of photoresist is here? Photoresist is positive photoresist. Area which is exposed will get weaker, area which is not exposed will get stronger. So, after this I have to perform, let us say step number 6, step number 7, right, 6 is done. Step number 7, I will dip this wafer, I will dip this wafer in photoresist developer, or I will develop this photoresist in a photoresist developer. So, photoresist developer, right. When I do that, what will I obtain? I will get photoresist in this particular fashion. Photoresist SiO2, this is your heater, this is again your SiO2, this is your silicon and this is your SiO2, right. After that, what is the next step? After this, what is the next step? We have to, so you see photoresist is protecting the rest of the area of heater except the contact pads, right. So, now after this PR developer, I had to perform next step, which is my step number 8, that is your hard bake. Next step would be, step number 9 would be etch SiO2 from windows, right. This is window, right, this one is window. We are etching silicon dioxide from windows using buffer hydrofluoric acid. So, we have to dip this wafer in BHF and you will see that the oxide is removed, So, what you will see after this would be let me draw it once again. So, it is easier for us to understand. After dipping the wafer in the silicon dioxide etchant, what we will be looking at? You get it, and here I will have my photoresist. Photoresist, silicon dioxide, silicon dioxide, silicon dioxide, silicon heater. You got it? What is the difference here? You see here there is a silicon dioxide here everywhere on the heater. Here silicon dioxide is etched from the window, What is the next step? Step number 10 will be acetone dip. Will etch, we will strip off the acetone by dipping, we will strip off the photoresist, I am sorry, we will strip off the photoresist by dipping the wafer inside the acetone. So, if you strip off the photoresist, what you will have? I will draw here only. If you strip off the photoresist, you will have a wafer, which looks like this. correct, and that is what we want. We started with this particular wafer. When we reach to this wafer, where you see that the difference only between A and B is that now the contact area is open, but rest of the area is protected by silicon dioxide. The contact area of the heater is open, but rest of the area of the heater is protected by silicon dioxide. So, if you see the top view, will look similar to this, where everything is silicon dioxide and only the contact area you can see there is no silicon dioxide. After this only we can start our next step, and that is to deposit metal for interdigitated electrodes. So, we will see in the next module how you can deposit a metal on such a structure to form interdigitated electrodes. You understand the reason, right? The reason of removing the silicon dioxide or creating a window such that we can remove silicon dioxide was to take the contact from the heater. Otherwise, you cannot take the contact from the heater, because everything is insulating layer, everywhere you can see insulating layer, you get it. So, that is the advantage of removing silicon dioxide from your micro heater, and now we have to deposit a metal that can be used to, or that can be patterned to form interdigitated electrodes. So, that particular process of how to deposit a metal on this particular structure, right, to form interdigitated electrodes, and then you have to deposit piezoresistor material, and then you have to also deposit a gold pad, followed by SU8 pillars, followed by bulk micro machining, which is etching the silica from the back side to create a diaphragm. We will see in the next module. Till then, you just look at this module, understand it thoroughly, and I will see you in the next module. Till then, you take care.